Hello everybody. Once again I am here with you for the another session of this Fraunhofer's diffraction due to double slit. Fraunhofer's diffraction due to single slit we have seen in detail. Now let's see what exactly the changes are there regarding the Fraunhofer's diffraction due to double slits are there. So basically here in this Fraunhofer's diffraction due to double slit, the two things are going to be occurring, that is the interference and the diffraction. Both the things are there, but the diffraction overtaking this interference, and we have this pattern, diffraction pattern due to double slit is there. So if you look at this systematic diagram of this diffraction due to double slit, and here are the two things there, AB, and this is AB, and this is CD. These are the two slits where the light is going to be traveling, the transfer through this transparent part, and this BC is nothing but to be the opaque part is there. So this is what the BC. याच्यामध्ये डबल स्लिटमध्ये ए बी ह्याच्यातून लाईट पास होणार आहे आणि सी डी ह्याच्यातून लाईट पास होणार आहे. बी सी ही जेवढं आहे म्हणजे की ज्याची की विड्थ आपण बी म्हणलेलं आहे, इथं जर बघताल तर एवढ्या पार्टमधून लाईट पास होत नाही, म्हणून ह्या ए बी ही एक स्लिट आहे आणि सी डी ही एक स्लिट आहे, ज्याची की दोघांची पण विड्थ सारखीच ए एवढी आहे. पण हे बी सी जो आहे त्याची विड्थ जी आहे ती बी आहे, ती सुद्धा जवळपास सारखीच असते, पण तो ओपॅक पार्ट आहे म्हणून त्याला बी सी ॲज ए विड्थ दॅट स्लिट विड्थ इज नथिंग बट टू बी गिवन विथ द पार्ट बी. मग टोटल स्लिट जेव्हा आपण बघतो त्याच्यामध्ये ए बी हा एक ट्रान्सपरंट पार्ट ज्याची की विड्थ ए, सी डी इज द अनदर द लाईट पासिंग थ्रू दॅटची पण विड्थ ए, आणि बी सी हीची विड्थ जी इथं दाखवलेली आहे ते स्मॉल बीने आहे. So light is going to be traveling through this way. This x y are the positions through where the obstacles are there, and this mn is nothing but to be here as an your screen is there. So this mn is the screen where the images or the spots are going to be diffraction pattern you can see. So for the this type of the arrangement is there for the double slit Fraunhofer's diffraction is there. So already I told you that there are two parts, that is the first part is interference and the another part is to be as a diffraction is there. So as far as this systematic way the diffraction is there, how this interference and the diffraction both are playing role in this double slit. So let's see first part, that is the interference minima and the maxima. As we are aware about that, the interference pattern is also to be as an bright maxima and the minima, bright and dark and bright and dark असे आपल्याला interference pattern बघायला मिळतो. Superposition of two waves of the lights are there. Now in this case if you look at this is where the part which is to be as an given with this another diagram, that is 3b. Here if you look at this an is the normal drawn, and to find out the path, that is the cn is the path difference, and where the ab and the bc are the particularly we can say this is what the slit width we can say ac, ab and bc is there. So ab is small a and bc is small b, so the total width is to be slit width is to be a plus b, small a plus b is there. So when we are drawing this normal an this right angle triangle is going to be formed can or acn, whatever we can say. So here this is what the with the this travels the secondary when the light is incident, wavefront is incident on the slit, then this secondary wavefront is going to be traveling the direction inclining at an angle theta. Here it is shown with this is what the theta angle with the internal initial directions, and where this right angle triangle can and if we find out the sine theta, then sine theta will be Cn upon AC. But as the sine theta we have find out that Cn and AC is nothing but to be the slit width, where it is to be small a plus b is there. So this is what a plus b. So replacing these values of the Cn, we have now here in this case, when this relationship is to be AC is going to be replaced with this a plus b. So here we have the new relation, find out Cn path difference when we are going to be calculating. We have the relation small a plus b into sin theta. A plus b जे आहे ते इकडे जाईल आणि आपल्याला जी काही पाथ डिफरन्स जो मिळेल Cn is equal to small a plus b into sin theta we have. Now with this case again we have if the path difference now the maxima or the minima, bright maxima or the minima is totally depending on the path difference value, and if the path difference is equal to the odd multiples of lambda by 2, and theta gives the direction of the minima due to the interference of the secondary wavefront from the two slits. जसं की आपल्याला माहिती आहे तिथून सेकंडरी वेव्ह फ्रंट म्हणून काम करते आणि ड्यू टू दॅट द मिनिमा इज गोइंग टू बी फाइंड आउट we will find for the odd multiples, and already we have seen in this interference phenomena that Cn is nothing but to be given with small a plus b sin theta is equal to odd multiples, that's why 2n plus 1 lambda by 2. So putting the values for the 1 2 3, we have the theta 1 theta 2 corresponding to the direction of the minima can be obtained. So the minima will be obtained for the odd multiples of this lambda by 2, and we have sin theta n is equal to 2n plus 1 into lambda upon 2 into a plus b is there. So this is what the value for the odd multiples. If the secondary wavefront is traverse in the direction of the theta dash such that the path difference can be equals to the even multiples of the lambda by 2, then the bright maxima will be there, and then the path difference is nothing but to be given here with the value, that is the Cn is equal to a plus b sin theta n sin theta dash n, that is even multiples, that's why it is 2n lambda by 2. So the value will be here n lambda by 2 because 2 will get cancelled here, and we have the relationship, that is the sin theta n dash is equal to n lambda upon a plus b, small a plus b is there. So putting the values for the n, that is 1 2 3, we have the theta 1 dash theta 2 dash theta 3 dash corresponding to the direction of the maxima can be obtained in this case, and that will be the value for the bright maxima. If I want to find out the difference of this angle for the odd multiples, sin theta 1 will be, we have relation sin theta 1 जर आपण calculate केला odd multiples साठी, then I have the value, that is 3n, sorry, that is the sin theta 1 is equal to, I have that is the value, it is 3 lambda by 2 into a plus b. Again sin theta 2 is nothing but to be equal to 5 lambda upon 2 into a plus b. So if difference I will calculate, that is sin theta 2 minus sin theta 1, then we have the relation. If you look at this is again carefully, so if you look at this case where the sin theta 2 minus sin theta 1 is equal to 5 lambda upon 2a plus b minus 3 lambda upon 2a plus b, that will simply giving us 2 lambda divided by 2 into a plus b. So 2 will get cancelled and we have lambda upon a plus b. So that is what the case where the angular separation between the any two consecutive minima is nothing but to be lambda upon a plus b is there. where the angular separation is inversely proportional to slit distance, that is a plus b, the distance between the two slit is there, that is small a plus b is to be there. And this is what the interference occur in this Fraunhofer's diffraction due to double slit. But the diffraction maxima and the minima is going to be occurred again at the same stage, only the angle is going to be, let's we have to consider the secondary wave traveling in the direction inclined at an angle instead of theta. Here will be the phi with the initial direction of the diffraction of the incident light. And if the path difference here it is to be bm is equal to lambda, so here it is quite interesting, bm. So let's check it out, the same direct diagram here it is to be there. आता ह्या ठिकाणी जे अँगल आहे, डिफ्रॅक्शन पॅटर्न जो आपल्याला मिळणार आहे हा ए बी मुळे एवढ्या पार्टमुळे मिळतो, आणि इंटरफरन्स जे आपल्याला मिळाले ते दॅट इज ए सी एवढा ह्याच्यावर. आता ह्या डिफ्रॅक्शन पॅटर्न म्हणजे इथं काय होते की बेंडिंग ऑफ लाईट इज डिफ्रॅक्शन, वी नो दॅट दिस ए बी इज सपोज टू बी लॅम्बडा अँड द इन्क्लाइंड अँगल इथं थिटा न घेता आपण फाय म्हणलेलं आहे. सो दॅट विल फॉर द आवर कन्सिडरेशन दॅट इज टू बी ॲज अन differentiation in between the interference and the diffraction च्या सोपं जावं म्हणून आपण अँगल फक्त तिथं फाय असं म्हणलेलं आहे. सो इन दॅट केस द इफ द पाथ डिफरन्स बी एम इट इज इक्वल टू द लॅम्बडा, म्हणजे इन्सिडंट लाईटच्या वेवलेंथ एवढा, त्याच्यामध्ये पण हाफ जो आहे अप्पर हाफ आणि लोअर हाफ दॅट विल बी लॅम्बडा बाय 2 अँड लॅम्बडा बाय 2 अशा पद्धतीने राहील, डिफ्रॅक्शनसाठी सांगतोय. So in that case, if the path difference bm is lambda, in that case the phi with the direction of the inclining with the inclining angle of phi and the initial direction to the diffraction of the incident light, that is if the path difference for the bm is lambda and phi will gives the direction of the our diffraction minima will be there, and the path difference between the secondary waves from the slit, that is point A and B, is equal to lambda at that stage. And considering the wavefront on the AB to be made up of the two halves, as I already told you, that is upper and the lower half, and the path difference between these two AB is the corresponding upper and lower half is lambda by 2, and the effect at the p dash due to the wavefront incident on AB is 0. Similarly, for the same case will be for the CD, that is for the direction of the secondary waves for the effect of the p dash due to the wavefront इन्सिडंट ऑन द सी डी, म्हणजे जिथून की लाईट पास होते ए बी आणि सी डी ह्या दोन स्लिट जसं की आपण म्हणलो, तिथं सुद्धा जे काही इफेक्ट ॲट पी डॅश ड्यू टू दिस वेव फ्रंट इन्सिडंट ऑन द स्लिट सी डी इज ऑल्सो टू बी 0, अँड दॅट्स वाय हिअर द वॉट एवर बी दी sign of phi we can calculate in that case. For this case it is nothing but to be a sin phi n is equal to n lambda. So in this case we have a is nothing but to be that width, ab ची जी width आहे ती a आणि cd ची सुद्धा width जी आहे ती small a आहे, आणि त्यानुसार आपण a sin theta n phi n is nothing but to be n lambda and multiples of this case, and putting these values for the n is equal to 1 2 3 we can corresponding minima of will be obtained, and maxima the central bright p point आपल्याला मिळणार आहे, पण जे inclined angle phi 1 आहे that will be cause the minima, and that minimas are going to be calculated with this a sin phi n is equal to n lambda multiples in that case, and this is what the way the diffraction and the minima in the Fraunhofer's diffraction due to double slit is there. So in this case the diffraction is going to be overtaking due to the whatever be the angles are concerned, and due to that interference is the overtaken by this diffraction, and that's why we are learning this Fraunhofer's diffraction due to double slit in a diffraction pattern. So thank you for joining this session. Be at home and be safe. Thank you.